Allemaal bij deze eerste parallel ochtendssessie. Deze sessie zal 2 talks over configuration management hebben. And I'll switch to English now, and the first talk will be about Puppet, and the next one about Ansible, and the Puppet talk will be given by J.H.A.
Okay, can you hear me? Okay, good. So I'm going to talk about Puppet performance profiling. I've been a Puppet user since 0.22 days. I wrote M Collective, XLOOKUP, J.H.A. Currently doing some independent consulting around Puppet and this kind of thing. And you can find me on various places on the web, Twitter, and IRC and such. So why do we care how fast Puppet runs? There's many reasons. I'm not going to try and list a whole lot of them. But these days, a lot of us do unit and integration testing. So we build up virtual machines and we tear them down between each commit. I've seen places where that would take 25 minutes, so that's not really good for people's fast feedback loops and this kind of stuff. Maybe you're using a cloud and you want to do more horizontal scaling. I've seen people try and build machines out from scratch each time they try to do auto-scaling, and then 5 or 6 minutes takes them to boot up the machines. That's not very fast response to demand. People have maintenance windows, people want fast feedback on those things. Puppet Master isn't particularly fast, so people tend to run a large estate in groups or in batches and this kind of thing. And very soon an hour maintenance window gives you only 1 chance to run Puppet on individual machines. So you get that faster, maybe you have a chance to recover from failure which you've done or a problem you've encountered. The Puppet Master is not very fast, so the less time that a specific Puppet agent runs, the less time specific processes or threads in the Puppet Master is engaged, and therefore you have more available capacity to run more concurrent puppets. That's just a few reasons. I could never list all of the reasons why you want the thing to go fast, but you can see the kind of reasons people care for how fast Puppet is. Of course, when Puppet is just doing its normal half an hour wake up run phases, it's not really the end of the world if it takes a long time or a short time. But when you really want to get a giant shot, it really matters. So to understand where we want to look at the various aspects of Puppet's performance, you have to understand how the conversation happens between an agent and the Puppet Master. The first thing that happens is the agent wakes up, it asks Factor for all of the facts. It runs loads of Ruby code, a little bits of shell scripts maybe, a little bits of parses text files, YAML files, whatever. But it gathers all the facts. It then sends those facts off to the Puppet Master, and along with the facts goes a request to compile the catalog, which is the artifact that the Puppet Master produces and that the agent then applies onto the node. The master compiles it. Compiling is basically the act of reading your code, understanding what you've written, finding all the classes you're including, and figuring out what you want, all your relationships, all this kind of stuff. Agent gets the catalog, stores it on disk, which surprisingly can take quite a while. It then starts a process of going through the catalog in order, which is a tree of resources, and just applies them all. At the end of it, it sends a report off to the Puppet Master. The Puppet Master then receives a report, processes it, saves it to disk, saves it to PuppetDB, whatever happens with it. That's the basic life cycle of a Puppet run. There's actually quite a lot more to it, especially when you start copying files and stuff like that. Today I'm going to look at the 3 things with the asterisks next to them. I'm not going to talk about all of the aspects of the performance improvements or performance profiling, just that. So first up, Factor. Factor at first is a simple little thing. It just runs a little bit of code, returns a key and a value, and sends it off to the Puppet Master or shows it. But if you maybe communicate with APIs, or maybe you speak to slow remote services to get information about this machine, or you speak to EC2's instance metadata, all of these things can time out, they can be slow to respond, and therefore this can add up quite a bit. if you run factor on your command line with -- timing, it will print out how long every fact takes to resolve. So to show you, I guess, the life cycle of writing a bad fact and making it a little bit better for performance, I wrote a little fact that speaks to an online service called freegeoip.net. Yes. You hit the URL freegeoip.net/JSON. It returns the JSON structure with where you are, information like your coordinates, which city you are, which country you're in, province, and so forth. I parse the JSON, loop over the JSON, get the keys and the values, and then add individual facts. Now, the thing you would think that when you run factor minus timing, that it's going to show you how long all of this takes. What it's actually going to show you is how long the stuff in between the set code braces take. It's only the set codes that are timed. So in this case, as you can see, I'm fetching the URL outside of the set code. And so it looks like my fact is really, really fast. But I know from running a thing on Go, it can take 5 or 6 seconds. So because I've written a bad fact, I can't profile it, I can't see what's going on. So let's restructure the fact a little bit. In the loop there, I know which are all the maximum amount of keys I'm going to go back from freegeoip. I loop over every key. The first loop iteration, I fetch the JSON and parse it. I store it. On subsequent iterations of this loop, I won't fetch the JSON. It will reuse the previously fetched JSON, and then it just adds the facts with an additional bit of feature where it will add unknown for missing data. So now we can see that factor minus timing is showing me the information. It says it took 7.1 seconds to fetch the first fact, and afterwards all the facts are fast because it reuses information. So if you're writing facts, put all your logic that can potentially be slow or blocking or anything like that inside the set codes, and then you can profile it with the built-in tools. So this is great. My machines don't tend to move countries often, so it seems a bit stupid to fetch this information every single time. So as a small improvement, I added a method that just fetches it once and stores it locally in a cache, in temp. And then the first time that you run factor, it's going to fetch this JSON, and all future times it won't fetch JSON at all. It will be then fast. You'd want a little bit more error handling there, so that if the JSON parse fails or something like that, you don't store a null or something. But so that's a basic idea. So when you're thinking about facts, they seem like small things, but it's fairly easy to mess up and write a fact that's really, really slow, or write a fact that's impossible to find out why it's slow without adding a bunch of prints and puts and this kind of stuff to stand it out. Any questions on factor? No? Okay. So moving on, we're looking at the process of compiling the catalog. This happens on your Puppet master, or if you run Puppet apply, it's going to happen shortly after receiving the facts. And this is where Puppet goes and reads your code. Like, it reads the stuff you've written, it tries to decipher it, it syntax validates it, it tries to fetch data from Hiera, it runs all functions, it processes all templates, interpolates all of this data, all this kind of stuff happens on the master during the compilation phase. And there's a lot of things you can do to make it perform badly. So if we're looking at a very simple class, this is just an Apache class. It takes one argument, version, default to present. It validates that version is a string, or they've done a little bit better validation there, and then it installs the package of the version. This is by no means supposed to be a complete class. This is just to show you the basic step that's going to happen when Puppet tries to read your code. At some point, you'll have had to write include Apache. Maybe in a node block, or maybe from your ENC, or somewhere along the line you indicate to Puppet you wish to include this, this class. Puppet then has to find it. So there's the standard module path structure that's been created for where your classes need to live, and Puppet will try and look in very specific locations through your environment's module path to find it. In the case of the basic class Apache, that's very easy. It should live in inner.pp, and it's going to be in the top of your module. But when it comes to the Apache package one, the line I have there, it will come across a line, and now it has to try and find the code related to Puppet to Apache package. If you don't put the 2 colons in front, it's first going to try and find modules Apache/package. When that fails, it's going to go 1 tree up until it eventually finds package.pp. And of course, if you use environments, it's going to do that for, if you have a module path that's multiple directories, it's going to go through this process for every one of those directories. Now you might think that how much work can it possibly be to find such a file? It's just to find a file on this. It's like a stat or something. Puppet does a whole bunch of stats. If we look at this little bit of code here, that's enough to build out a Puppet master. If I run it from scratch, it's 10,500 stats on the file system, just to run those 5 lines of code. If we just validate that one, if we validate it and we limit it to just the act of finding your modules, that's 217 stats that needs to do. So maybe your code lives on NFS or on some kind of shared cluster file system or something along these lines. 217 stats isn't too much, but if you have 1,000 machines checking in, and of course we don't all have such small manifests, people manage 500-600 resources, this adds up to a really vast amount of file system traffic. And so doing simple things like having the colon in front of your classes when you're including them, it can literally halve the amount of work it needed to find a specific class on disk. So once it's found the class on disk, it opens it, it reads the text, and it starts going through that. Since Puppet 3, if you have an argument, it will do a hierarchy lookup for you automatically. Who uses hierarchy? Okay. How big's your hierarchies? 10, 5, 2. Okay, good. So the way hierarchy works is it will try and find this Apache colon version piece of data across a whole tree structure of files, and because people can be updating your Git checkouts while the compilation happens, this kind of stuff, it tries to do this every time it hits a hierarchy lookup. It's going to walk the tree. It can't cache it. There's a little bit of caching in. Once it's figured out that the file does exist and hasn't changed, it will reuse the previous parsing of the file, but it can't cache the fact that the file exists or doesn't exist. It needs to find it every single time. So don't do that. This is a hierarchy I got of IRC from someone, and with a little bit of a check against that same class, it's doing 3,500 searches for files on disk, just compiling those 5 lines. So that's quite a lot. And this is because people have long argument lists. Like this is obviously configures PuppetDB and Puppet Master, but there's quite a few arguments in these classes. It's going to try and find them all, and it's going to try and find them all in every tier of this hierarchy until it finds it. So it can be quite heavy. Multiply that by, say, 1,000 machines, and that's all. Okay. So think about your hierarchy sizes. Think about how you write your classes. Use the hints that the Puppet supports and where to find your files. Don't use the relative lookup feature in finding variables or classes. So then we're on to the next line, which is function. Functions are bits of Ruby code. In this instance, you would hope it's fast. It just checks if it's a string. But people write functions to query APIs. People write functions to query LDAP, all those kinds of stuff. And pretty much the same things that we saw in the fact applies in this case as well. If you're interacting with remote services, cache stuff if you can. Don't talk to it 100 times during every compile. It will really slow things down for you. And then comes up here, even if it's already read the file, as far as the class is in memory, it does this relative lookup search even in memory to try and find your classes. And at least for some versions, I think around 3.3, there was a really, really bad bug with this stuff. People saw like 50% increase in compile time. And it was like because they didn't put those two colors in front of their classes. It's quite an expensive operation, even though it's only in memory. They've optimized that, it's a lot better now, but it's just good to specify those things for multiple reasons. And because we're supplying a version specifically here, we're giving it an actual authoritative answer value, that won't do a hierarchy lookup. So taking the approach where you have one class where all your variables enters into your module, and then accessing that variables or passing them around internally, that speeds things up tremendously. In this instance, you might imagine that the Apache package has, the class has a number of arguments, things like what the package name is. Is it Apache 2, is it HTTP on Red Hat or Debian? If I don't supply the information to it over here, it's going to do a hierarchy lookup. If you write the class in such a way that instead of having that piece of information present on two classes, just do it once, that'll save you 50% of your hierarchy lookups. Significant speed up. Okay, so any question on this stuff? This is simple. Any questions there or hints or anything? Okay. So the compiler around early version 3 days got a profiler built into it, where it will show you as it goes through and reads your code what it's doing, how fast it is. And it's really handy, but it's like a wall of text of information. Generally, I would say don't run your Puppet Master with this setting enabled, because you're going to get vast amounts of log lines written, and you're not going to know which node is for which node and this kind of stuff. And you will also not be able to easily tell what's steps involved with reading the files, finding the files, and what steps involved with compiling the code. So in this example, I use Puppet Apply. Puppet Apply has the compile function built into it, and it starts, of course, fresh with every invocation. So you have a clean Puppet environment, and it starts reading your code from the beginning. So let's have a look. Is that readable? Hopefully. So I give the 5 lines of code over there, and as soon as it starts compiling it, you can see it's going to read the Apple class, which has the main init.pp. That class inherits from params of pp. It reads that file. It then has to go and do the same for PuppetDB, which is the main class, which inherits from params of pp. So we're already 4 files in, and each of those files were found with many, many stats. Then it shows you it's busy reading the thing. So in the EPEL manifest, there's a bunch of function calls to define, to downcase, to validate which is a regular expression validation. And it shows you how long those functions take. So if you've written any custom functions and you see your catalog compile times are slow, run the profiler. It will show you whether your functions are the cause for the slowdown. And this way you can find out, where to focus your activities on. It then goes through, in case it finds a PuppetDB server, bunch of stats, and starts running your code, and it just does that, loads and loads of text as it compiles. Nice thing what it also does, it shows you your templates, because templates are Ruby code. People do all kinds of things in templates. They speak to databases, they query MySQL. These things can take quite a lot of time. Here it shows you it found the template on disk. Again, loads of stats. Did the variable binding, taking all of your variables from your manifest, passing it into the template system, and how long it took to turn that template into a static block of text. 0.5 seconds in this case. But of course, if you have templates that do a lot of database stuff, so this can be quite long. At the end, it shows you a little summary of how long things took. There'll be loads of stuff in there. Like, it's a massive summary of things. I'm only showing a few things, but we can see the complete catalog compile took 5 seconds. So it took literally 5 seconds to parse those 5 lines of code, and their included classes. It had to read all of the resources that you've defined. There's 79 of them in this instance, and that took 1.5 seconds. It shows you how long each individual resource takes. So maybe you wrote your own type or your own providers. They could be performing slow, so it will show you which ones, how long it takes. And then it shows you for all of the function calls took 1 millisecond, really fast. Yeah, and it shows you then the whole list of them, how long each of them took. Unfortunately, this information is just, there are some tools that have been written to summarize the stuff out into a nice thing, but and I was hoping to maybe write something that can pull out, the top 5 slow things for you or something, but haven't really gotten around to that because the format of these profile messages keeps changing between versions. Puppet 4 is due soon, so I'm not going to touch that stuff until they've done changing all of that code. Maybe we'll write a little report for that information. Any questions on compiling? No? Okay. So the next phase of the agent lifecycle, it's receive the catalog. This is a massive JSON file or a YAML file in older versions of Puppet. It saves this thing on the disk, which actually involves parsing the JSON, recreating a new blob of JSON, and writing it out the disk. This can take 5, 6, 7 seconds sometimes on large catalogs with loads of resources or loads of files in them. There's been attempts made to speed this up. You can change the format of that on-disk serialized information to message back, I think. That speeds it up a bit, but there doesn't seem to be widely adopted solutions to that. So there's not much I can do for you about that. It's slow. If you run Puppet agent ---- test and you add --eval trace to the end of the command line, it will then show you as it goes through every single resource. Whether those resources have something to do or not, it shows you how long it takes. So here, there's a bunch of resources. Most of them they were already in the desired state. It had to install package mailcap, and we can see that took 65 seconds for some other reason. This is a Red Hat machine that probably had to build all its YAML caches and all this kind of stuff. So immediately you can see by just reading this stuff what's going on. But on a machine with 600-700 resources, that's 1,200 lines of code. So it's probably not great. So I wrote a little. It has all of this information, and it keeps it in memory, all of the performance profiling data, and it stores it into reports. So if you have reports on PuppetDB, or if you have reports on disk from a Puppet Master's store report processor, you can access that information for past catalog applications going back in history. So maybe you can graph the stuff, or you can see how your improvements change over time. So as you're working on your manifest to try and speed them up, save those reports, and you can see improvement over time. Reading reports is not great. They're massive JSON files, really, really massive files. So I wrote a console-based report processor that reads those reports and show you the information from the perspective of performance, wanting to understand what's going on. So count 5, we'll see later on, it's going to show me the 5 slowest resources and the 5 biggest files. So you can change that to 100 or whatever you want. And the report is just those YAML files that the Puppet Master produce when you have the store report processor enabled. Just one by default, I think. It shows you which machine, when it was run, where to find the file. It's not the correct path there. Which version of Puppet, So maybe you upgrade, maybe there's a bug fix, performance fix in Puppet, you upgrade Puppet versions, you can get this information in the reports, see how long to complete the runtime took, if there was a marked improvement by upgrading Puppet. Your configuration version, which comes from this configurable thing, and if there's any log lines produced while Puppet ran, it can even print those out for you. If you add it, minus log. The UUID that was shown there, that's the UUID that you can use in PuppetDB to find the same report if you store your reports in PuppetDB. So it shows you a bunch of metrics. I've truncated the bottom list here. There's quite a few more stuff that it will show you. In this instance, there were 2 changes made. One, of course, was the mailcap application, a package that had installed, and the other was probably the service that restarted as a result of installing the package. Both of those events succeeded. It was able to install the package and restart the service. Out of a total of 213 resources on this machine, 2 of them was out of sync, 2 of them changed, and none of the stuff failed or anything like that. So you can get quite a bit of information out of the report to find out whether this is was this thing, for instance, running slow because it had to do 50 package installs. And of course, it's not going to try to do those things in parallel. It can call YAML at each time for each package that you come across. So when you're looking at reports, make sure you compare apples to apples. Make sure if you have a report that made no changes, compare it to another one that made no changes. It then shows you per type how fast or slow things were. So here we can see it took 28.44 seconds in total to run this agent. I don't think this slide and a few slides back actually lines up. There's probably different Puppet runs, but yeah, package took 15 seconds to run, installing that one package. It took 7 seconds to retrieve the catalog from the Puppet master. That is the process of sending the fax, compiling the catalog, and receiving the catalog back from the Puppet master. So the first part of the talk. And then files and XX and all the various types you have on your catalog. It shows you how many of each specific type of resource you have. So there's quite a few files, 107 files in this catalog, loads of INI settings, a couple of XX. File is important to keep an eye on because the way that Puppet works when it manages a file, if you say the file should have this content, it MD5s a file. And the file, of course, lives on the Puppet master. So even if there's no change that needs to be made, it needs to find out whether or not this file has changed. So that's a new HTTPS connection to the Puppet master, asking to give me the MD5. If the MD5 has changed, it's a new HTTPS connection fetching the file and saving onto disk. So this is why managing 100,000 files suck, because it's 200,000 HTTPS connections if you're starting fresh. It's not great. And even if nothing's changed, it's 100,000 HTTPS connections. Until early on in the 3.7 cycle, there was no pooling or connection reuse. It's literally 100,000 new HTTPS connections. It's pretty bad. Those are 4 packets each, just to create them, 2 packets to shut them down. That's round trips to your Puppet master. It adds up to a lot of time. Since late in 3.7, they've put in a pooled connections. And so it will reuse existing HTTPS connections. That showed significant speed up, but still there's a lot of work to and fro between a Puppet master. So, don't use Puppet as a file server for your websites or RPMs or any of those kind of stuff. It's not what it's for. Configure something like rsync with Puppet, that's what it's for. With files, it's only going to do this round trip thing if you use source. If you use content, it saves that content, the text of the file, in the catalog. It'll blow your catalog up in size, but it doesn't have to do these round trips with the Puppet Master to put that file on disk. So, a bit of a trade-off, but it can help. So, you can look at the list of resources and go, damn, I'm managing lots of files, I probably shouldn't be doing that. So this is just kind of some overview information about what's going on inside that catalog. It then goes through, and this is where the --count5 command line summary came in, or command line option came in. It will show you the slowest resources by evaluation time. So, package took some time. That PuppeDB con validator resource makes a telnet connection to the PuppeDB's port because it's a Java application, of course. You start the service, it takes 5 minutes to come up. So that resource is in the PuppeDB package, in the PuppeDB module, and it tries to connect to the port until the port listens. So if the PuppeDB goes down, if you have to restart PuppeDB, that resource will take a long time, as long as the Java process takes to start, for instance. So this just gives you a place to go start looking at. Package is really crap, maybe I should install a local package mirror. Or maybe I should pre-bake a bunch of these things into my images that I should ship out to the cloud using something like Packer or whatever. There's loads of different approaches to speed up the catalog application phase, but it depends unfortunately on what types and what providers. So you have to understand what happens underneath in order to decide how to make it faster. The last thing that my report processor will show you is 4 files where your file resource name is a full path. It will check if it can find that file on disk, and it will show you the top 5 biggest ones. So, if file serving is particularly slow from the previous bits in the report processor, you can have a quick hit list here to go and see which are the ones you want to look at. Yeah, so that's a little report. I'll give you the link to the report processor at the end of the talk. But that will analyze your reports for you and show you from a performance perspective what to improve on and what to maybe do less of. And so, in cases where you have a slow public, like it's slow, it's shit. You want to start ideally from something like this report on your agent, because that will show you bits of information from all the various life cycle that it goes through. So if we look at the beginning here, the config retrieval time. That's how long your compile took and how long it took it to save it to disk. If that's particularly long, you either have bad code and the Puppet Master is having issues parsing it, or your Puppet Master is just busy. It can't serve your compile request now, so your request was on the queue. So that gives you a hint as that's where you maybe should start looking. You can start looking at your times here during your agents, and then the furthest information shows you what bits you're going to optimize. And things people do is, pre-bake images. If you're on EC2, install your Java into your image when you bake it, because you're probably going to install your Java everywhere if you're in a microservices kind of Java application. So there's no need in getting Puppet to do it all the time, and that kind of thing speeds you up. There's no silver bullets, unfortunately. It all depends on exactly what you do in your infrastructure, what kind of resources you have, what kind of things you do, and what your goals are for speeding things up. And that's about it. The fact that I wrote is on the first URL. There's only 3 commits in that fact, and that's from bad to slightly better to with the cache. So you can have a good look at the life cycle of that code, and the report processor is the second URL. You can just download that and run it on the machines and get this information out. Any questions?
Will you put up the slides as well?
I will put it up, yeah.
No questions? Okay then, thank you.
Cool.